In this video, we're going to do some extra examples for nth roots and rational exponents and going in between the two. So just remember that the nth root of a equals b is the same thing as saying a is equal to b to the power n. Okay, so that's what we're using. Okay, so let's just go down to the examples here. So in this first one, we want to simplify, and we're assuming that the variables are positive, so we don't have to worry about any absolute values. Okay, so the first thing we're going to do, we're using the rules for the roots above to break this up. So you can break it up. We can start by breaking up it into 2 bits, so the top. So it's the fourth root of 16x to the 5 divided by the fourth root of 81y to the 4. We can break it up further because now they're multiplying. So on the top, it's the fourth root of 16 times the fourth root x to the 5 over the fourth root of 81 times the fourth root of y to the 4. Now the fourth root of 16 is 2. And maybe I'll just write that since. So 2 to the power 4 is equal to 16. Also, x to the 5 is equal to x to the 4 times x. So we could actually break that down further as well. So it's the fourth root of x to the 4 times the fourth root of x. Now the fourth root of 81 is actually 3. So again, 3 to the 4 is actually 81. And the fourth root of y to the 4, because y we know is positive, that's just y. So we don't, if we didn't know y was positive, we want absolute values there. Okay, similarly, x is positive, so the fourth root of x to the 4 is just x. So we get 2x times the fourth root of x over 3y as our final simplification. Okay, let's try another one. So here I have 5 root 8 times negative 3 root 3. So we can multiply the numbers. So 5 times negative 3, that's negative 15. Now 8 is 4 times 2, so we could break it down as root of 4 times root of 2, and then we still have the root of 3. Okay, so this part is equal to the root of 8. Root of 4 is something we know. Okay, that's 2. So this is negative 15 times 2 times root of 2 times 3. So that's going to be negative 30. And then root of 2 times root of 3 we can put together as root of 2 times 3 or root of 6. So we get negative 30 root 6. Okay, now here we want to rationalize the denominator. So in part B here, I want to make sure that this root 7 is gone. So what I'm going to do is use this difference of squares tool. So I'm going to multiply by the conjugate. So the conjugate has the same 2 pieces, so root 7 and 2, with the opposite sign in between them. So because it's a plus, it's going to be a minus here. Whatever I do to the top, I have to also do to the bottom, so that I'm multiplying by a fancy 1. Okay, so then when I expand, the root 2 goes in. So I have root 2 times root 7 minus 2 root 2 all over, and now it's going to end up being root 7 squared minus 2 squared. Okay, root 7 times root 2 we can write as root 14. Okay, minus 2 root 2. And on the bottom, I have 7 minus 4. Oops. So I end up with root of 14. Oops. Okay, root of 14 minus 2 root 2 all over 3. Okay, now we're going to do another one. Same idea here. So we multiply by the conjugate. So that's going to be root 3 minus 3 root 5. And then I have to do that on the top as well. Oops. Okay, so expanding the top is going to be root 2 times root 3 minus 3 root 2 root 5. And then on the bottom, I'm going to have root 3 squared minus 3 root 5 squared. Okay, so root 2 times root 3, that's root 6. Minus 3 root 2 times root 5, that's root 10. And then I'm going to have 3 minus 5. So root of 5 squared is 5. Times 3 squared is 9. So that's going to be 45. Okay, so then I have root 6 minus 3 root 10 over negative 42. Okay, now if you want it to look nicer, you could bring the negative up. So you can switch the order here. So it's 3 root 10 minus root 6 over positive 42. Either way is fine, but that one looks a bit nicer. Okay, just a couple more here. So here we want to simplify so that we only have positive exponents. So 25 to the 3 over 2. This is the same as square root of 25 to the power 3, or 25 cubed square rooted. But this way is a bit easier to compute. So because we know the root of 25 is 5, it's going to be 5 cubed, or 125 is 5 cubed. Okay, now down here, we're going to use the exponent rules. So I can bring the exponents in. So this is x to the 1/4 times y to the 1/4 times x squared to the 1/2 times y squared to the 1/2 all over x squared to the 3 over 4 times y to the 3 over 4. Okay, now simplifying these exponents, we're assuming that the variables are positive again. So x to the 1 over 4, y to the 1 over 4. And then this is going to be x to the 1 and y to the 1, because 2 times 1/2 is 1. Down here, I'm going to have x to the 2 times 3 over 4 is actually 3 over 2. And y to the 3 over 4. So then on the top, I have x to the 1 over 4 plus 1, so that's 5 over 4. And I also have y to the 5 over 4, divided by x to the 3 over 2, y to the 3 over 4. So now I can subtract the exponents, so it's x to the 5 over 4 minus, actually I'm not going to write that. Okay, so let's just write it over here. 5 over 4 minus 3 over 2. Okay, that is 5 over 4 minus 6 over 4. So it's going to be negative 1 over 4. Okay, and then y to the 5 over, so here for the y, we're taking this exponent minus this exponent. They have the same denominator already. So it's actually going to be 5 over 4 minus 3 over 4 is 2 over 4, which is actually 1 over 2. Now we don't want negative exponents, so we just drop that to the bottom, and I'm going to switch it back to roots. So it's root of y over the 4th root of x as our final simplification here. So that's simplifying some roots and rational exponents.